Right. So today we are going to look at module 5 of the Cloud Practitioner or Cloud Foundation course from AWS, which is networking and content delivery. Right. So to overview this module, we have some topics. As you can see, we'll review our networking concepts, which we may have done previously, networking basics, that is, and then we will get introduced to Amazon VPC, which is virtual private cloud, right? And then we will look at how VPC networking is done. We will also see how security is configured in VPC, right? Well, and then we'll get introduced to a couple of concepts called Route 53 and CloudFront, which are operational, basically operational. These are we configure these as well to improve the networking services, right? Route 53 and CloudFront. We'll look at that. You'll do a lab, which is a part of your assignment, practical 1 as well. For assignment practical 1, right? We'll do a lab that's tomorrow on lab class. We'll do a VPC and launch a web server. You'll obviously complete your knowledge check. I will do VPC demonstration as well today in the lecture, and there are a few activities which we are going to do to kind of understand the theoretical concept which we are going to discuss in today's module. Right, these are the objectives, and you can see basically it says you would recognize, understand, or either or do hands-on on whatever we just said here, whatever topics we are going to cover. So I'll not read those things out to save time. Let's start directly with networking basics, right? So what is a network? Right? Network is a ordered, if I may say, collection of computers, basically, in a simple sense, right? So you have group of computers which wants to communicate to each other, obviously, right? And we organize them in a structure. Basically, that's a network, isn't it? We know what network is, but right? So you'll have a network where you can organize bunch of computers. The purpose is to make computers to communicate with each other. Now they are usually connected with wires. They can be connected wirelessly as well. What we'll simply for now will say wires, right? Or wirelessly they are connected with some means. Now, network, that group which we organize, bunch of computers to communicate with each other. That's the purpose, right? That can be further subdivided as well into smaller groups, and that's called subnet. Basically, you have big network. Let's say you have 20 computers or 200 computers. Now you can subdivide that group into 100 and 100, for example, computers, and we call those subnets as we call those smaller groups as subnet. So subgroup as subnet. Network is the whole thing, and then if you divide network further down to organize it better, then we call them as subnet. As simple as that. Now, if you have group of computers, right, which are divided into subnets, so you'll have basically, theoretically, you have two networks, right? For example, let's say this is one network. It is actually a subnetwork, but let's assume this is a network, another network, which has bunch of computers, connected to each other. And if those subnets, or let's say full network wants to communicate, then we'll need to have a device which connects them together. That device could be a switch, a hub, or could be a router, right? So switch and hub, we are not going to, in VPC context, we don't configure, we directly say router. What does a router do? Router connects two different networks, right? Or two different subnetworks, so to say subnet 1 and 2, and route traffics, right? So any request coming from here, request will have where to go, who to respond, something like that, the format, and the router will take it and deliver that request to the the destination which is specified in the request. And if a response comes, it will route to the source. So that's what router does, basically routes the traffic, right? That's a basic kind of internet. Now, each of these network, the group of computers, has to be identified by some name, isn't it? Like we have a class, right? We have a class of NI604, and we have 20, 30 students here. Each of us have name. As a tutor, I have name, you have name. So I identify Chris by his name, similarly Jason by his name. Similarly, in this group of computers, they also have to be identified, right? So they are given an identifier, which is called IP address, Internet Protocol Address. So TCP IP, protocol fully. Now, people who have done networking, all these concepts are clear to you. But if you have not done networking, so I'm going a little bit slow and just to understand. So each of these computers will have a name, which is called IP addresses, right? Now, in an IP address, there are two types of IP addresses. This is called IPv4 and IPv6, right? So this IP version 4, in short, we call IPv4, and IP version 6, that is IP Internet Protocol version 6. So 6 is a long address, and that's a little bit, we need to understand a bit more. IPv4 is very, well, what would we say? It's easier to understand. So we'll start with IPv4. No one stops us to, use IPv6 as well, but we'll start with IPv4. An example IPv4 address, you can see it's like this, right? 192, you can see an address. So this address, or this, you can say name of computer or address simply of the computer, 192.0.2.0. Now, each of these, when we read it or when we write it somewhere, right, we write it in decimal system, like 192, it could be 168. You can put any number here, not any number, but number here, right, or number here, and we read it in a decimal format, decimal system, 192, this 192, right? We don't say 192, we say 192, 168, something like that, right? But when computers process it, everything in computer is converted into binary to process things, right? We know. So these IP addresses, name of the computer or identifier of a computer, will also be converted into binary. Now, this dot, you can see, they separate a number from 0 to 255. 0 to 2. We have used 192. We could have used any number from 0 to 255 here. 0 to 255 here, 0 to 255 here, 0 to 255 here, any number. And that could represent a computer, a router, or any resource, a switch in a network. We could give that identifier or that IP address to any resources, anything which is actually connected into a network, right? So you can see here 0, right? 0 to 255 in binary, if we have a space, that could represent 0 to 255 number, you'll need 8 bits. Now, how these bits are read? Now, you see, this is 2 to the power 0, right? This is 2 to the power 1. So you start from least significant bit and go all the way to most significant bit. So this is 2 to the power 0, right? This is 2 to the power 1. This is 2 to the power 2. And this is 2 to the power 4. So, and then it increments in, the power increments in 2s, right? The number increases in 2 to the power, not power increases in 2 to the power, right? So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, and 5, 2 to the power, that is 6, right? 2 to the power 7, 2 to the power 8 or something. So 2 to the power 0 is what? 1, isn't it? 2 to the power 2 is 2. And we add all these numbers and finally it becomes one number. And that we write here. For example, you see 0 is all zeros, right? Here you see 2 to the power 0, that's 0. So we are not going to add that. 2 to the power 1, right? that we are not going to add because it's 0. Now 2 to the power, similarly 2, 3, 4, 5. Now up to here, it's all 0, right? 0, 1, 2, 3, 4, 5. Now 6 and 7 are 1, 1. That means we'll add 2 to the power 6 plus 2 to the power 7, which basically means 192. 2 to the power 7 is what? 128, is it? What is 2 to the power 6? Okay, I was asking, but anyways. So 2 to the power 6 is 64, isn't it? And if you add 2 to the power 6, right? If you add 2 to the power 6, well, 1, 2, 4, 8, 16, 32, 64, and 128 it should be, right? So 2 to the power 7 is 128. 2 to the power 6 should be 64, right? Not 30. Anyways, maybe my question is wrong, a little bit different. Anyways, right? So that's how you represent 192, right? We need to understand its binary form as well, because next we are going to look at is what we call CIDR, CIDR notation, but we'll look at that, right? So IPv4 addresses, the example we saw here, right? It's a 32-bit. How? First 8-bit, second 8-bit, third 8-bit, and fourth 8-bit. So you have 32 bits. So IPv4 address basically consists of 32 bits, 8 bits, 8 bits, 8 bits, and 8 bits. You see, if you add up, it's 32 bits. We have IPv6 address, which is 128-bit. And an example looks like this. Now, we will rarely use IPv6 address, so I'm not going to explain that, although in networking class, you may have known. In lab, we can always go through this IPv6 address and everything, right? So there is a notation which we need to understand, because this notation is going to be used to create, virtual private cloud, subnets, everything in VPC, in AWS. So the notation is called classless interdomain routing, or CIDR, right? So basically, CIDR, you can see an example is here. So this is an IP address we just looked at, 32-bit IP address, right? 192.168.0.2.0. Then it adds slash and then a number, right? Slash. So 192.0.0.2.0 slash 24 or any other number. What does this mean? What is this identifier is? Now, after slash, you will have a number. In this case, we have 24, right? This means that 24 bits are fixed. Out of 32-bit address, 24 bits are fixed and is a network identifier, right? So this is 24 bits are fixed, routing prefix or network identifier. So this identifies which node network we are working on. Network has an address as well, right? How do you know if you have multiple network, which network we are working on, right? Which network we want to use? So network should have identifier. And how do we identify? By looking the number after the slash. So if it is 16, let's say, then 16 bit are fixed. Fixed would mean that's a network identifier. So 16 bit, that means the first octet here, 8 bit, and other octet 8 bit are fixed, and they are used to identify network. We cannot use those IP addresses, right? We can't change these IP addresses, this is fixed, to represent a host, right? Now, if we have 24, that means 3 octet, right? 1 octet, 8, 16, and 24. They are fixed, right? So remaining one, so in this case, in 24, we'll have 8, right? Remaining 8 bits are flexible, and flexible as in we can use this to give it to any computer or any resource within that network, within this network, right? So you have 8 bits, that means you can have 256 different IPs. Right? 2 to the power 8 is 256. So you can have 256 different IPs. It could start from, let's say, 192.0.2, that's fixed, 1 or 2, 3, 4, up to 256. In fact, starts from 0, so it will be 255. The last address you can use to give to any resource or computer within that network is 192.0.2.255. So you'll have, from starting from 0, you'll have 256 different resources, computers, whatever you say, printer, right? Any resource within that network, you can give that. So 2 things to remember. You just look at an IP address, we identify that IP address, and after slash, you look at the number here. It could be 16, it could be 24, it could be 28. And then we understand that, that many bits, whatever number here is, right, that many bits are fixed, or that is a network identifier that identifies the network we are working on. And remaining bits are, we can utilize those bits assigned to any host within that network. So basically they are host identifier. Right? Now, open system interconnection or OSI model. Again, networking students may have gone through this. We'll quickly see how it looks like, right? So basically it has 7 layers. You can see from layer 1 to 7. Like layer 1 is basically physical transmission. So everything is converted into binary, raw data bits, raw bit streams, transmission and reception of raw bit streams over a physical medium, right? Hubs. So any data comes over, let's say, your network card, up to network card. The transmission, that's physical layer. Then you have data link layer, which basically is used to transfer data in the same LAN network, that includes bridges and switches. So from your computer to the first hub, could be a switch, could be another computer within that network, right? Could be anything, right? So it uses MAC addresses. So every NIC has MAC. We know that, right? MAC address. So up until here, IP doesn't play role if you are only communicating within a network. Now these are network concepts. We don't need to go detailed with that unless you have a question. Network layer, you can see that's layer 3. When going from down, that routing and packet forwarding. So basically a router. If a computer wants to communicate with a computer which is in another network or in another subnet, or it's an internet, it has to go through some device, and usually that's a router, which takes the request and routes it to proper destination, right? You have transport layer then, which supports TCP, Transport Control Protocol, UDP, right? These protocols provides protocols to support host to host communication. So these routers can route the request, right? But we need to have a protocol to follow that when we are communicating. I mean, if a host generates an address, it is meant to be for another host in another network or another subnet. Now we need to have a full stack kind of protocol which takes packet and delivers. What kind of packet is that? What kind of request is that? So all these are defined in TCP and UDP. UDP is used for wireless, TCP is used for wired connection. So these protocols actually determine what type of that packet is and which application that packet should go for. You have session, right? Enables orderly exchange of data. You have RPC, NetBIOS kind of protocol here. Then you have presentation layer, which ensures that application layer can read the data. Encryption and all those things happen in presentation layer. If you are using TLS, that's transport layer security, then encryption happens here. All security happens here. If you are using IPsec, for example, right, then encryption and everything happens here at network layer. Please remember, right? For other application layer security, encryption and authentication, like using MAC, hash function, so many other things happens here. The prime example is TLS, the SSL, which web uses, right? Then finally, the application layer means for an application to access the computer network. right? And there are a few protocols defined here for HTTP, FTP, TCP, LDAP, and many other things. Now, we don't need to understand all of this. Some of these things will be important to configure our network, configure as well as secure our network. That is, some TCP, some of the ports. Definitely we need to understand IP, how IP works, and some of the ports like HTTPS, which port HTTPS uses. Although if you don't remember, we'll see how it does. But these things, if we are familiar with, that will help. So that's about the revision of networking concepts. Again, if we are not coming from a networking class, networking 1 class in this class, if you have not come from there, we can always go into detail. Please ask me in lab. We can separately discuss all these concepts, right? Now let's come to the Amazon VPC, the AWS VPC, which we are talking about, right? So what is an Amazon VPC, or what is simply VPC? Let's say why to keep repeating Amazon word, right? So Amazon VPC is a concept which enables us to provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So basically, you create a virtual network within AWS cloud, right? And that's a private network in a way, right? Within that network, you keep all your resources. So you are creating a network basically, right? And it's in cloud, so we say virtual. You are creating a network. Within that network, you can create sub-networks, which is called subnets and other things, right? So while doing that, if we do that, it gives us control over the virtual networking resources, whatever resources we want, that including the selection of IP addresses. So which resources gets what identifier, that is IP. You can select, we can configure, we can create subnetworks, or in other words, we can create subnets within that network or cloud or VPC in Amazon terms, right? And we can also configure route tables, network gateways, both of which is actually used to route traffic. So if a computer 192.168, let's say 1.3 has sent a request, right, to same network identifier 4. Now, these route tables will route those traffic to the real destination, the destination which you are actually sending to. So we can configure that, all those things. Now, route tables, network gateways, or firewall concept could be a little bit daunting if you have done network 1. However, in Amazon VPC, in Amazon Cloud, right, it's very easy. We just need to remember a few things and everything we can configure and understand, right? So the whole networking concept is not required, is what I'm saying. This routing, routing in a switch or configuring a Cisco firewall could be, a good task, but we don't need to do that. It's all done for us. We just need to understand what it is doing and configure it, as I'll show you in demo going forward. It also enables us to customize network configuration for our VPC, right? Also used to use multiple layers of security. All these things are there. We need to configure. We'll see how to configure and everything, right? Now, VPC and subnets. Now, see, in this picture, you can see, right? This is a simple representation of a VPC, right? Now, AWS cloud is the whole cloud where we log in, right? Within that cloud, we know region. And remember, in one of the tasks previously, we also looked at the resources and its availability at what level. So some of them are available at subnet level, some of them are available at region level, some of them are available at global level, right? Remember, the IAM service was available at global level. Now, VPC is generally available at region level, right? So you have AWS clouds. Within that AWS cloud, you have region. We can select region. So region sits in AWS cloud. We can say, right, Sydney region, Singapore region, wherever region we want to select. We have talked about regions, all these things in AWS global infrastructure module, right? Within that region, you have availability zones. that we have talked. Now, at region level, we can configure or we can create a VPC, virtual private cloud. We can create our own network. Within that network, we can create subnetworks. That is called subnets, right? And it's generally a good idea to keep those subnets in different availability zone, right? You can see zone 1, zone 2, zone 3. So region had availability zones. We know that, right? We have, looked at it before, or if else, we'll look at it again anyways, right? So you can configure a VPC, which a region level service, which is a region level service. It can span over all the availability zones. But when we create subnets, now a subnet can only reside in one available zone. A subnet can only reside in one available zone. Remember that, right? But we can create multiple subnets within same zone. That's not a problem technically. But it is recommended that if you create multiple subnets, put that into different availability zone for a production kind of a network, right? For development, for learning, yes, we can put all subnets in one availability zone. When we start configuring, it will make more sense maybe, right? So here, VPC, what's VPC? Logically isolated from other VPC. It's a regional level services, right? You can create as many VPC as you want within the region, right? Delegated to, and that VPC will, everything you create will be associated with your account, right? The root account or the IAM account you have created. You can, obviously create IAM account like we did last week and work on this, right? Start creating VPC, so that will be associated with that particular account which you have used to log in and create all these things. And it belongs to a single AWS region. So it's AWS region services, like region level services, and can span over multiple availability zone, is what we just saw in this picture, right? You can create subnetworks, that is subnets within that VPC. So we are basically dividing that VPC into multiple parts to organize things. We'll see, right? So subnets will have range of IP addresses that divide VPC. Basically, with IP addresses, we divide VPC and belong to a single availability zone. A single availability zone. Subnet you can't create a subnet across availability zone. You can create here within that, right? And subnet, you can make it as private and public as per your need. So obviously, in public subnets, you will keep resources which are public. That means can be accessed from outside, for example, from internet, or if you have VPN set up from your office. But private subnet, you don't want to give access to those resources which you want to keep in private. That's why they are by name public and private, right? IP addressing. So when we create a VPC, right, we assign it to an IPv4 CIDR block, right? So basically a range of private IPv4 addresses, right? So basically, this number could be, we know, from 0 to 255, anything, right? This X could be anything between 0 to 255, right? So you have for 32-bit address because we are using IPv4 CIDR block, right? So basically a VPC can, in theory, contain, right? In Amazon Web Services, that AWS can contain 65,536 addresses. So 65,536 different resources you can put in a VPC. The minimum here is 16 addresses. Now, all this is determined by, as you can see, the CIDR notation, right? /16/28, right? /16 means what? 16-bit of this IP address is network identifier. In other words, you can say fixed. Whatever, things, whichever way you want to understand it. Different literature have different way of saying, right? So if they are fixed, that means they are used for network ID. That's a network ID in a way. We can say network identifier. So 16-bit means first 8-bit. So first X, second X, which will have 8-bit. This you cannot use. Now you have remaining 16 bits. So it's 32 bits, right? So remaining 60 bits. Now all of these addresses, you can assign it to hosts. That's why 2 to the power 16 different addresses. That's why we have this many 65,536. So that's the maximum in a VPC we can use, right? Minimum is /28. That means 28 bit are fixed, right? 28 bit are fixed in this. So 24, that's 8, 8, 8, 8 plus 8, 8 plus 8, right? That's 24 plus 4 from this octet. So they are fixed. That means we only have 4 bits to play with. So we using that 4 bits, so 28 minus 32 is 4 bits, we can actually have 16 different addresses. That's minimum. That's not a general concept. It's a Amazon VPC concept. Within an Amazon VPC, you can do that, right? In general networking, you can use up to maybe, all addresses. 1 bit you can just fix and you can use. And theoretically, I'm saying no one does that, but theoretically, just 1 bit you can fix and do theoretically. Others can be assigned to any of the addresses or any of the resources within that network. In Amazon VPC, you can only have 16 and 28. Minimum is 28, the mask, and 16 is the maximum. So you can have these many resources there, right? And that's enough, to be honest, right? Within a VPC. If you need more addresses, you can always create another VPC, isn't it? Right? So when you create a VPC, you assign it to an IPv4 CIDR block, range of private IPv4 addresses. We cannot change the address range after we create the VPC. So once you attach a CIDR block or range of IP addresses to a VPC, you cannot change it. The largest is /16, CIDR block /16, which is basically 65,536, and minimum is 28. We are just saying, right? IPv6 is also supported. Now it has different block size limit. A lot of people do not use IPv6 anyway, right? CIDR blocks of subnets cannot overlap. So if you have created 2 subnets, it should have separate IP groups, IP ranges, right? Cannot overlap. We'll see what that exactly means when it comes to that, right? So there are a few reserved addresses as well, right? So for example, and that's again within Amazon VPC concept. This is Amazon VPC concept, right? Example, a VPC with an IPv4 CIDR of block 10.0. is a class A, right? I purposefully skip class A, class B, class C, those kind of addresses, because that's not required. And we are not the networking class anyway, right? Just enough to understand what we need to understand from network, right? So 10.0.0.0, right? /16 would mean what? It has 65,536 total IP addresses, right? Why? Because 16 bits are fixed. First 8 bit, second 8 bit. That means these 2 octets, right? Octal numbers, we are free to use. So 2 to the power 16 different addresses we can use. Now, this VPC then can be divided into 4 equal size subnets, as you can see in this figure, right? You can see first, so 10.0.020, right? That's fine. Now, that's your VPC address you assigned. Now, first, you created a subnet, and then you assign 10. Same, right? 10.0 to 0.0.0.0/24, right? /24 mean what? So that /24 would mean you will have 24 bit fixed here. You have only this place. These are 8 bits to play with, right? So 2 to the power 8 is 256 IPs. So you can put 256 IP into, you can use these 256 IP to put in whatever resources you have. So 256 different resources, let's say. That's a general thing, right? However, in each of these 256, 5 of these IP addresses are reserved, and that is reserved by AWS, right? So for example, here, in this case, 10.0.0.0.1.2.3, and the final one, 255, we cannot use for our resources. They have, first one is definitely a network address. We know that, right? .1 is they have reserved for internal communication, their internal communication. 2 is domain name service or DNS resolution for them. They have just reserved 3 for some future use, right? If they need some IP. The final one is network broadcast address. We know that. We don't use that to assign to any computer. So in between that, we have 251 different addresses. So for each subnet, you can see 5 of those addresses are always reserved. We can't assign. So from 0 to 3 and the final one, 255. Now, coming back to subnet, you see there are 4 subnets. You see, they've changed. Now here 1, subnet 4, subnet 1 was .0/24. Now it's 10.0.2.0. So you just change here /24, right? So these 3 are fixed. Network identifier, you can change bit here, then it becomes different network, right? Different network or different subnet, you can say, or in this case, right? Different subnetwork. 24, because we have already given this range to a VPC, to a bigger network, we can say, right? And 1.0/24, another subnet, 3.0, another subnet, right? You can change these 3 here as well. You can keep it 0, no problems. 10.3.0.0/24. Again, we'll have, that will be a network identifier, a subnet identifier here, right? And /24 mean we will have, in theory, 256 addresses, but because 5 addresses are reserved, so you can only use 251 IP addresses. No one stops you to divide subnet, like, if you need only 16 IP addresses. So you simply have 28 here. You can make 25, 26, 27, up to 28, depending on how many hosts you need within a subnet, right? Public IP addresses type. Now, we know what public IP address is, right? So these addresses, you see, 192.10 dot something and 192.168, we start. These are private addresses which directly cannot communicate with internet. The IP addresses which can communicate directly with internet, right? In a very simple sense, you can simply say they are public IP addresses, not private IP addresses, right? So public IP addresses, right? We can manually assign a public IP address through what we call elastic IP address. Now, this elastic IP address, remember, is a chargeable resource. They charge you if you use a elastic public address. There is a default public address which is assigned to resources when you are creating. If you want to create, so auto assigned, there is an option. They are free. But if you want to add an elastic IP address, then it will be chargeable. Now, it would be better if when we were doing, I'll review this concept, but for now, we'll just say elastic IP addresses basically are fixed addresses. What does that mean when I say fixed? Now, you created an EC2, right? We have been creating EC2 in a few labs, a virtual machine, and that virtual machine gets an IP, auto-assigned IP. That's a public IP. You can switch it off just to have in private network. You don't want to assign a public IP, right? It will automatically get a private IP. However, if you want to give them public IP, simply do auto-assign. While creating, it will get a public IP, right? But when you restart somehow by accident, or when you restart that server or that particular EC2 instance, then the IP address will change. It will get another IP from DHCP, right? And you don't want to do that. If that EC2 is hosting, for example, a web server, it needs a fixed public IP, isn't it? In that case, you will give elastic IP. What do you say? We buy elastic IP interface. We'll see how we can add. I'll show you just in a while. And we can actually, that IP address will be fixed to that particular EC2, and you can host any server there. So for fixed, we add elastic, and there is automatically assigned through the auto-assigned public IP address settings at the subnet level. So 2 ways, and this is free. Manually assigned elastic IP address is chargeable, right? You can assign and deallocate because we are practicing. Even you configure a web server, you can always attach an IP address and deattach it, right? There's elastic network interface. For now, I'll simply say, when you add an elastic IP, you are actually adding a virtual network interface that has that IP fixed associated with it. You can attach it to any instance, usually for EC2, right? Or gateways, we'll see as we go. Right? Route tables and routes. Now, by name, you would guess what it does, it routes. So we defined rules. A route table contains a set of rules. We define rules there, which we can configure to direct network traffic from subnet. So from each subnet, what traffic goes where, kind of thing, we can actually define. It has basically two. You can see two entries. That's destination and target. Now, destination in this case is what? 10.0.0.0/16. So this is a VPC address, isn't it? Just not VPC address in general, but in this example we gave this VPC, this address. So any traffic, this says basically in this route is the destination traffic, then target is local within that VPC, right? Unless we create a rule where we can add a rule which goes outside that VPC as well, not local but outside. We'll see that. That's VPC CIDR block, right? So each route specifies a destination and a target. We see by default every route table contains a local route for communication within the VPC. That's a local route. Yeah, each subnet must be associated with a route table, and it is at most one route table for each subnet. You can have multiple rules, but have only one route table. Now, we just looked at what VPC is. A VPC is a logically isolated section of AWS, right? VPC is a regional resource, a region level resource. And to identify that VPC, we need to give them a CIDR block. That's basically a range of IP addresses, right? Now, VPC can then further divide it into subnets. We can have as many subnets as our range IP range allows. Now, we do that to keep better organize our resources, like into private, public, yeah, and many other things. A subnet belongs to one availability zone. So it's an availability zone level thing, right? And requires a CIDR block. We saw that, right? Route tables can be associated with VPC. There's default route tables as well. We can edit that, or we can create a new route table and associate with a subnet with a VPC as well, right? Route tables have a built-in local route. We'll see as an example, and if we need, we can add additional routes to the table, right? A local route cannot be deleted because then nothing will be accessible, right? Within that particular subnet or VPC. Now let's look at VPC networking, right? So look at this picture. What do you see here, right? So you have a AWS cloud. You can see the whole cloud. The outer margin is within that we have a region, right? Within that region, we have one availability zone, right? The availability zone is, you can say within that availability zone, we have multiple data centers. We have gone through all those things, right? So within that, right, we created a VPC, assigned it a CIDR block or IP address, that's 10.0.0.0/16, right? Further, we created a public subnet. There are two types of subnet, a public subnet and a private subnet. We know, right? So public subnet, and within that public subnet, we have some resources, let's say EC2. This is EC2. So we keep one EC2 inside public, one EC2 inside the private subnet, right? These things will be the public subnet, and we have something called net gateway also. Next we'll look at, but this thing is associated. So anything, any traffic, any resource will generate traffic. That's why we have put it, right? Will be routed through a route table. Now, because it is public, right? We know we attach something called internet gateway. IGW ID, something. It's kind of default name for an internet gateway within AWS, right? Why? We need to connect that subnet to internet. So from internet, we can access that subnet and resources within that subnet. When we say access that subnet, means resources within that subnet, isn't it? That's a default thing we know, right? And that has to be defined using a route table. So using that internet gateway, you can communicate with internet and vice versa. So outbound and inbound traffic. Yeah. So now a sample subnet route table, you can see here, public subnet route table, right? We have destination and target. Like we saw, a route table has two entries, destination and target. First is default entry, that's between local within. So all these resources, all these traffic within this VPC goes to local, something like that. Right? Target is local. Now, any traffic like 0.0.0.0 you see, we don't have any number. So all this traffic, that means any traffic coming from outside or anywhere, should go through IGW ID, that is Internet Gateway. Now, if we add this rule, our subnet becomes available from outside. Yeah, you can simply SSH from your computer to access any resources within AWS cloud, right? That we are going to see anyway, right? Now, you see, network address translation NAT gateway. Now, this is for public IP, right? Public subnet. You add internet gateway, simply this subnet becomes available to outside traffic. Now, what happens with this private subnet? Right? How do you make it available outside this VPC or VPC or to all, maybe for the internet? What we call is NAT gateway. So we can add a resource, NAT gateway. Now remember that this NAT gateway should be added into public subnet. Although this resources is supposed to make this private subnet, right? Private subnet available to, let's say, other subnets or outside, right? Simply outside this boundary, right? But this NAT gateway should be implemented within public, should be kept within public subnet. It will have a route table, obviously, we can configure, right? And this subnet route table, an example, this we already have seen because of the internet gateway, right? The public subnet route table, private subnet route table will have this entry, you see, any traffic outside. This is basically any, right? When we say 0.0.0.0 means any IP addresses. Traffic coming from any other IP addresses. Any IP addresses should be routed to NAT gateway. And that's through NAT gateway, you can access any resources within the private subnet. So that's for, to access resources within private subnet, we need a NAT gateway, right? Remember, NAT gateway again is a chargeable service. Internet gateway also is chargeable service. Now, NAT gateway, when we create NAT gateway, we have to add an elastic IP. Remember the elastic IP we just talked about, and that is chargeable as well. Now we have $100 to play with all these things. So if our sandbox doesn't allow us to play these things, we can always use that and we'll do the exercise in lab, right? Another concept is called VPC sharing. Yeah. So by name you can see, and this picture, right? You see. Now VPC can be shared within different accounts. So you have created an IAM, you have a root account for an organization, then you have so many departments there. Each department can have its own VPC, and they might have organized their resource within subnets within their own VPC, right? And each of these VPC could be associated with different departments account. Would have administration, tutors, tutor group, something, right? A manager's account. Using IAM, you have created an each VPC associated with that account, right? All these can be shared now. Shared as in you can access basically, right? For example, you have VPC account A. Account A has created this VPC, which has private subnet, have EC2 resources as EC2 instances. You have databases, right? Account B, participant, account C as a participant, right? And you have a public subnet. Same here, right? But this VPC, although honor is account A, can be shared with account B and account C. We can configure that. That's called VPC sharing, right? This is a little bit more, a little bit advanced concept, usually architecting content, but yeah, to understand this, we can actually do that. It's not that difficult. We'll see in practicals. Third thing, another thing is called VPC peering. Now, this VPC peering, this is sharing is between accounts, right? Within a region. See, there is a region, right? Same reason you have different accounts, you are sharing VPC because when you create a VPC, your account owns it. How do you give access to another account is what we are basically doing, right? VPC sharing. Now, VPC peering, on the other hand, you can do within AWS cloud. So there is no restriction in any region. So you can create a VPC within Sydney region, right? And you have another, let's say you have a business, big business account, big business, and it has branches all over the world. All over the world, AWS is actually, AWS has divided, its services according to regions. So VPC belongs to one region. So Sydney region, let's say, and then you have another office in Singapore region. How do you share all the resources, or how do you give access to those resources, which is sitting in Sydney region within a VPC, which you have created, to another region? That's called VPC peering. Now you have a resource called VPC peering. We can configure that resource in order for VPC B, which is in Singapore, let's say, and VPC A, which is in Sydney B, access each other resources. Now, access restriction can be always, depending on what kind of access your business needs, you can give those configuration. But what we are saying is access. We can access that, right? And that's called VPC peering. And we have a resource to do that, VPC peering. So simply drag that resource, configure it properly, right? And do. While doing that in VPC peering connection, you'll need to update both route tables for VPC. You see, simply, this is default one for local, right? For local target. Now, for others, so this VPC, you can see, for route table A, you should add an entry for this VPC to this peering. So basically, any traffic coming from this VPC should go to this peering connection, and this peering connection then will forward to this. So any request from originating from this VPC to access a resource from this VPC, right? VPC A will go through peering connection. Similarly, for VPC B, you have this VPC ID. VPC ID block should go to PCX ID. So any resources coming from these IPs, any requests coming from these IPs will go here. Because we have peering connection, it will route it to VPC B. That's basically, you can connect VPCs in your own AWS account, and multiple VPC you can create in a single account if we need, between AWS account, which we said VPC sharing, or between AWS region, right? So anywhere within AWS, we can have a VPC. Now, there are some restrictions, obviously. You see, IP at spaces cannot overlap. See, they are different, right? VPC is this one. This has, although, same 65.366 address, 65.366, the network ID is different, 10.3.0.0, right? Different, so they can't overlap, right? Transitive peering is not supported. Now, what is transitive peering here? What does they mean by transitive peering? So let's say VPC A is paired with VPC B, let's say, right? Now we have seen how to do that. Now, VPC B is, let's say, paired with VPC C, another VPC, which could be anywhere, same well, between another region, any other region. Now, A and C cannot communicate with unless we create a separate peer connection. It's not transitive, right? So basically, in transitive mathematics, what we say, A equals B and B equals C, then A equals also C, isn't it? That's transitive relation in basic algebra, basic mathematics, right? That doesn't apply here, right? So if you have to create separate peering connection between two VPCs, just because VPC B is connected to A, and VPC B is connected to C, A and C cannot communicate, right? And we can only have one peering resource, right, between the same two VPCs. We can't have multiple peering resources within that. We don't need or we can't have, right? Another thing now is AWS site-to-site VPN. You see, this picture, we have been looking at it here. I mean, it's the same from the previous slide. You see, there is a region. Within that region, you have only one availability zone. You have created two public subnet and a private subnet within that VPC, created a VPC and subnet, right? And you have a route table which routes traffic to something called virtual gateway, right? And this virtual gateway again is a resource. You can add that, right? Which is connected to internet, right? There is something called customer gateway, again a VPS AWS resource. Now, why we use this? Now, let's say we have office. Welltech has an office, right? And we need a connection to AWS, direct connection through internet, right? Through internet connection to AWS resources. So we can use basically AWS resource as a customer gateway, right? Which will have entries, which will guide any traffic originating from customer data, corporate data center or the business office to AWS. So it's basically, if you have some resources you want to put in AWS, but if you have some resources which you want to keep in your office, in your business site, right? Then this kind of connection is applicable and you can configure it, right? That's called site-to-site VPN, a virtual private network connection. So in a way, a part of your network resources are in on-premises and a part of your resources are in VPN, AWS cloud. And you can connect it using site-to-site VPN connection. To configure, we need virtual gateway and customer gateway. So customer gateway is sitting outside, not in cloud, which will have entries to find this virtual gateway, right? And once it is found, traffic can be routed within that VPC, right? So basically here, you see, any traffic from here, see, from public subnet route table, right? We have any traffic coming will go to internet gateway, which is not shown here, right? But from private subnet here, you see the traffic entry here. This subnet, right? This IP, I suppose, this 192.168.10.0 is coming from this network. Yeah, that's the not assume, but that's the corporate data center network. It goes to this virtual gateway ID, and that we need to route. When we create, we need to add this kind of entry. So anything coming from this network, which is outside in on-premises network, should go to this virtual gateway, and you need to know where to route it. Yeah. Another service AWS gives us is called AWS Direct Connect. Remember, the difference between this connection VPN to site-to-site VPN connection and direct connection is we don't have internet. Now you can have a direct connection. So basically you are making a WAN, isn't it? Right? So that's called AWS Direct Connect. So using that service, you can connect your full on-premises or partly on-premises network to the network or to the VPC or resources you have configured in AWS using something called AWS Direct Connect. Yeah, it doesn't need internet now. Yeah, for VPN connection, virtual private network connection, we need internet. Remember, you must have used many VPNs. Even in fact, to connect to the B Labs, we used to call B Labs. Now it is T6 Labs computer within the Welltech, right? We have Cisco VPN connect. So you have to use Cisco VPN to connect to our computer. Same concept here. We are connecting to the site will connecting to AWS, right? VPC. Within that VPC, you have many resources. If you want to access that, you will configure site-to-site VPN connection that will connect through the internet. Now, AWS Direct, if you use AWS Direct Connect, we can have VPN, direct virtual private network, does not use internet, right? So you can connect on-premises and cloud resources or cloud networks together using AWS Connect, AWS Direct Connect. There is something called VPC endpoints as well, right? Now you have two types of VPC endpoints, right? One is interface endpoints powered by AWS Private Link, and another is gateway, which is endpoints, right? Which is basically used for Amazon S3 and Amazon DynamoDB. If you have those resources within your VPC or subnet, right? So endpoint, the job of endpoint is to make this direct, AWS Direct, more effective as well, right? More effective, right? So we'll see how it works. Now you have AWS Cloud Hierarchy. Within that, we have a region. Within region availability zone, you have two subnets within a VPC called this, right? Now we can add an endpoint, right, which will give us default DNS hostname or endpoint specific hostname, right? You need to have an elastic network interface. We looked at what elastic network interface as that, right? Within that VPC, we have added, you see, a VPC endpoint. And this VPC endpoint can be connected to some storage services, some hard disks, XPR hard disks. You see, we need storage, so we have configured that, or any databases, right? That directly can connect to those resources. Now, all of these resources within this VPC can access that storage, which is outside that VPC or outside the network which you have defined. For that, we need VPC endpoint. We can add VPC endpoint, right? Obviously, for public subnet route table, you will add this entry. So this, whatever this is, this should go from the traffic coming or going from this one is VPC ID, well, Amazon S3 ID, this one, right? S3 storage to this VPC endpoint ID. All right. It may look it's too much something or daunting, but you see, when you start configuring, it will be very easy. I'll show you, right? So there's something called AWS Transit Gateway, right, which simplifies this kind of, in a way, messy, configuration to simply this hub and spoke, you can say, right, topology, right? So here on the left hand side, you can see, right, you have customer gateway, you have VPN connection, and then that is connected to Amazon VPC, right? Let's say this one. You do same thing, this one, right? So you need your data center to be connected to AWS Cloud, right? Now that VPC, this is connected to a VPC, right? This VPC could be paired with another VPC using VPC pairing, right? This VPC then can be connected with another VPC. They all sit in someone in US, Singapore, or blah, 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 so many other places using VPC, right? And this VPC may need VPN connection to, again, customer gateway, right? Now, and that is, connected to, without internet, this VPC is connected to this Amazon VPC, something like that, or using VPN connection, you connected to customer gateway. And behind this, you have on-premises infrastructure, whatever. So this looks really messy, and to understand also it's difficult, right? So now, instead of this, you simply can have something called AWS Transit Gateway, where each of these VPC can connect, right? And VPN connection, this VPN connection can connect as well. And now this VPN can have a customer gateway connection like that. But all these VPC, you see, can be connected using AWS Transit Gateway. It's very easy, right? This VPC now can connect to this, can connect to this, and so forth, and so on, just to make it easier. So one central hub can connect multiple resources, multiple VPCs, multiple direct connected gateway, VPN connection using UEach. Now, why do we need these two things? To connect to on-premises, right? Outside infrastructure. This does not use internet. This uses internet, isn't it? Right? And these are VPCs within different region of AWS. This all can be connected centrally to one thing, and that will route traffic. So that will make life a lot easier. You can see from picture from this to this. Right. So there's an activity. So you have looked at a few slides. This picture. Now, just to check how much you have remembered, how much you have paid attention in other way, right? Can you fill up in your pen, paper, computer notes? Can you fill up these spaces and just remember that for this space, I have filled something, whatever you want, whatever you have filled. I'll give you like 2 minutes, let's say. Yeah, so it's 18. So I'll ask you on 20. Do not see the next slide. Just try, and because you are not showing me, so you can you can have you can do mistakes as well. Don't have to show me, right? So, but just try and see what are these symbols and what are these pictures. We saw this picture a few times in this class. Right. So it may not have been 2 minutes, but we'll try and save a bit more time for demo. Yeah. So anybody can tell me what is this? What would be the label here? Correct label? Okay, I need to look at that reason, right? A few you see, and I hope you have not seen my next slide, right? And what will be this? You can simply availability zone, or simply you can say edges, A and Z, so edges. What will be this one? Obviously VPC, right? That's correct. What will be this one? A public, that is subnet, right? Public subnet, right? And well, there's already this. What will be this? What is this one? No, this one, the IP address. Okay. Yeah. What is Q6? What is Q6? Anybody? Exactly, right? NAT. Now let's move to the private. Oh, I've already said this is a private subnet, right? What is this? Or this, we can say this question, right? Which is indicating this one. Elastic network interface, that's good, Byron. Again, right? So we know this, then we'll know this as well. What exactly is this? Yeah, internet gateway. So we have you have a few gateways. So we need to know what exactly which gateway, right? Internet gateway, and uh, and these are route entries. We know that, right? Route table entries, or IP of resources, right? The We can have two interface card. One is well, one interface can have two IP, right? One associated with the public IP, and another is private IP. Anyways, that's okay, right? Now, if we move on to this side, that's internet, right? Now, what is this? Question mark. What would be the entry here? Well, yes, yeah, I'm partially correct. And what would be the slash after that? 10.0.0, yes, slash 16. You can, have any slash, but yeah, that's your VPC IP ID, right? To local. And this one, IGW, that's internet gateway, right? Session, yeah, that's correct. That's correct. So basically, from any traffic, you have a public subnet here, right? If you want to access this public subnet, right, from outside, you need to have this entry, route table entry, which says from anywhere to where? The internet gateway, which will give us access to this public subnet. That's really good, right? We at least some of us replied. Although I would have, said, I would have, expected. I expected more people to participate. But anyways, yeah. So almost all of what we said is correct. As you can see, these are, so we at least we know how to read a diagram, because if we read this diagram, we can easily configure that into management console, isn't it? Not easily, but we can translate that. The topology, if you understand, we can translate exact topology to the cloud, which we are going to do soon. So let's look at the demo. Now, we have a recorded demo, right? We have a recorded demo, which is available here in your, here, see, somewhere, yeah? Console demonstration, but this actually covers same concept. I looked at it. However, the interface they are using is slight older than what the interface we are getting these days, right? So maybe they have, the when they created this education resources, the interface looked slightly different. Now, the interface I have opened here is AWS Management Console. We know now, right? It's a free trial account. You guys can, you have created and you can log in. Right? Now from here, that's networking and content delivery, right? So we can find this services group, networking and content delivery, or simply what we are actually looking at is VPC, right? We can simply find this VPC. Now I have used, because recently visited, it comes here. You can find it somewhere down, right? So content and, can we see content? Yeah, networking and content delivery, right? You can just go there, find a VPC here, right? Click this one, or simply, if you know what you are doing, you can simply search from here, right? VPC. When you open VPC, the VPC dashboard looks like this. It will load up. Remember the first class I said we need to have presence, right? Although I have, 1000 gig or something fiber connection, but from AWS, anyways, right? So this is VPC dashboard, right? You see, you click VPC dashboard, you have VPC, NAT gateways. If you have configured, all of these things will appear here. Now it's 000, everything, right? in Singapore, or am I in Singapore region? So I'll just say it to Sydney anyways, right? We know this Sydney. Now, if you map that picture, which we are looking at, the whole thing you can say is AWS cloud, the whole thing, right? Within that AWS cloud, we have a region. We select a region. Within that region, now we are going to do VPC or create VPC and do things, right? So now, see, if you click here, your VPC, it will show your VPCs, right? Here, we don't have any VPC. By default, each region in AWS has VPCs, which is called default VPC. So there is a default VPC. If you don't want to create your what you say, your resources within this VPC, that's fine. Although it's for testing purposes, right? For production network, you would like to create your own VPC. No, you don't use this VPC. It's called default VPC. How do we know it's default VPC? If you scroll a little bit here, somewhere it should say it's a VPC, default VPC. Tenancy is default. You have not created, right? Default VPC, yes. Right? Now you can see this VPC has network control list, main route table, the route table, and DHCP option set, all these things. If you click this, you can go and see what's happening here. What we want to do is we want to create a VPC from scratch. We will not use default VPC, although nobody stops you to use that VPC, that put resources in that VPC to learn, to test and all those things, right? But we'll try and create VPC. Now, to create VPC, if you see that video, they have older, I saw first few minutes and they had older interface, so I didn't see it. But concept-wise, please go and visit that video. Look at that video also. It will review concepts that will be good, right? Now, simply here, you can see, we can go to VPC dashboard, right? Initially, VPC dashboard, you can go from here. VPC, if you have created VPC, you can go and show from your VPC as well. Or click here. There are multiple places to click that, right? You come to this place. Your VPC is selected. Now you create VPC using a interface, or we can say button there. Sorry, excuse me. This is right. So you have two options you can see. Are you creating VPC only? So if you are a bit more experienced, you can use this option, or even without experience, you can use this option, right? It doesn't matter. It's basically you are creating VPC only, then you'll add subnets, you'll add route tables, and all those things yourself, which is what we want to do. But for demo purpose, right? In lab, I'll create a separate lab exercise, and I'll put the word I have found is challenge, right? Last lab, remember, Sam and all of us were discussing the optional word doesn't work for them. So I was looking for a word. Now I'll put a challenge lab, right? Where we will create everything ourselves. Here, if you select this option, you can see VPC and more. Now, on your right-hand side, or our right-hand side, right, you will see the diagram as well, right? Which gives us whatever option we select here in a diagramming. So VPC, so details, right? We can see details of each of these things now. That we'll see later. Let's come back to our left-hand side options. So in VPC and more, right? There is a name tag auto generation. So auto generate a name, you can project or you can change it. We'll just put it demo VPC. VPC something, whatever name you want to put it, right? Now, a VPC requires what? A CIDR block. Now, there is a default CIDR block, right? As long as we know what IP address is, basically we don't have to enter anything, right? We can make it as many, as whatever we want. I would like to have a custom IP. My network should start from 192.168.0.0, right? And I want full IP addresses, full max IP addresses. So I'll just put 16, right? So that means I have 65,536 different IP to put my resources with, right? For now, we'll not put IPv6 CIDR block. Otherwise, resources need to have IPv6, and IPv6, we need to understand IPv6 fully. Although I assume some of you understand, but we can always come back to do that later, right? So Amazon provided IPC set block. So we need to know all these things. That's why, right? Tenancy, we can make it default or dedicated, up to us, right? Number of availability zones. So we can choose 1, 2, 3, up to us, right? By default, it is 2. We'll just make it because we are learning, right? We can always make it 2. That's not a big difficult thing. We'll just put it 1, right? Just the diagram also looks a bit simplified, so we can understand, right? We can customize AP, you can see, right? If I choose 2, which 2 availability zone within this region I select. We can also have 3, yeah. So if we have 3 subnets, we can keep 1 subnet here, another subnet here, third subnet here, up to us. Or we can keep all of our subnets here. But the recommended practice is, if you have multiple subnets, please use multiple zone. But now we'll just use 1 zone. That is AP South 2 is A, whatever that name is. Now, create subnets, right? You can see here, right? Subnets. So you have VPC, demo VPC, which has this CIDR block. We haven't given IPv6, not required. Then by default, because 1 we have selected, you have 2 subnets. Number of public subnets, right? We can select 1 or 2. Now, because it's a recommended practice, you see, I have only selected 1 zone. So, it is giving me 1 public option, right? Only 1 subnet public and only 1 subnet or 2 subnets private, up to me, right? If I select 2, now, see, default public subnet becomes 2, right? And then private subnet up to 4, right? If I select 2 availability zones, I can select any of the availability zones. It's okay, right? Let's have 1 just to keep everything simple, right? Now, subnet, customized subnet CIDR blocks, you can see here, they have automatically given me this one. I can change this as well. It's my choice, right? So 4096 IPs. Now I don't have that many resources to keep in this subnet. So I'll just make it simple, right? I'll just make it, let's, for example, 124. Now, good thing is, some of you, if you are still confused with subnets, or not done networking class, you see, everything is done to learn, things are done by AWS for us. So if you, are confused in how to create subnet CIDR or something, one option is just ask me in the lab and we'll make everything clear, hopefully. If not, the default options, what they have given, you can still learn how to create VPC, how to create subnets in AWS, right? But if we know we want to change it, up to us. You see, I only need 256 resources, that's right. I can even make it 28. That's the minimum, right? Only 16 IPs, up to me what I require. I'll just make it as simple, 24 256 IP, right? Now here, 2, right? 1, then 2. Another subnet will start from 2 and I'll make it 24. So I have 256 IP. So private and public, right? Now, NAT gateways, right? So the default option is none. We can check. Now, why do we need NAT gateways? We were theoretically, when we are reviewing, we need NAT gateways for this private subnet to be able to communicate with other subnets or outside the private subnet. That's why we need NAT, right? Now, you see, there is a charge for NAT gateway. That's why while learning, you may not configure NAT gateways. You just keep resources to private subnet, which you don't want people to access from outside. As simple as that. Once you get into the computer, or once you get into that VPC, that public VPC, you can easily get into private subnet and access those resources as well. But if you want access outside, we will have. I have only first selected 1 AZ, so I'll get 1 AZ for NAT gateway, so that they will create for us, right? VPC endpoints, actually you can put a S3 gateway, Remember the last slide we saw before starting this diagram about endpoint? It actually directly connects the entire VPC to this gateway, S3 gateway, as in, the to access those resources, storage resources. We don't have created resources. We don't care for. We'll just put it none for now, right? These default option will use the DNS option enable DNS host names, DNS resolution. So if you want to, give a computer this IP, and then again you want to give these IPs as a name, like for example web server, you chris.com, something like that, you want to call a web server, it will have an IP, but if you give name chris.com, so these services will help to, if a traffic is coming for chris.com, then it will map to the IP which is the resource has assigned by default, or you have assigned. We'll go up to there. When you do this lab, tomorrow's lab, it will make even more sense. Now you simply do create VPC. Oh, I should have seen that picture as well. Anyways, that picture also will give you an idea, right? So when we work, yeah, I mean, sorry, Chris, if that's it was private IP address. Which one you are talking about? Yes, I mean, I would say yes or no. Just guess. I don't remember which you are talking about. I am a .com. Okay, whatever .com, right? I'm just giving web server. If you create a web server and if you want to give the web server name, because obviously people will browse using the name, right? Not 192.168 IP. So that DNS will resolve. DNS will create a binding between the name, whatever.com, and the IP. And those services are default, so we just created that, right? Now, all of these things are created. As you can see, they are allocating resources. Now, with AWS, right? When you are a little bit more experienced user, you can simply go and do other things and come back here if you have other things to do, like creating resource, like creating EC2 or something, because it will take some time. We don't have to wait the whole time here, as you can see here, right? So we are waiting for NAT gateways to activate. Remember, this NAT gateway will charge. It's a chargeable service, right? We have enough dollars though, $100 or $200 in your account. But just remember, these are chargeable service, and in a way, this is my rule of thumb, but rule is once you create any resources, right? Do practice everything. While leaving PC, just delete everything before you shut down. Don't say that I will remove you in evening, because that will then pay as you go kind of model. It will charge, right? If you have used expensive resources, then that $100 would go quickly, right? So just delete before when you come back. See, it doesn't take time. Even you create a lot of resources, it doesn't take much time, right? It's 10 minutes more if you have create everything again and start practicing. Obviously, in production environment, you will not do that. But while learning, right? Well, let's have a practice that whatever we create, remember what we have created and delete everything before we go, right? Now, see, that's the VPC we have created, right? You see that this VPC has resource map. You can see this resource map, demo VPC. It has two subnets, right? One public subnet, another private subnet. You can look at these private subnets and clicking here, right? Clicking here about that. Now it has three route tables, right? One route table, default route table made for VPC, another route table for one of these one of the subnet, another route table for another subnet, and this probably is the default subnet. We'll see each of these things, right? Now connections, we have created connections, right? Now this private route table, you see, automatically is connected to, because we are creating default one. We didn't add entries for route table, anything, but they did it for us. Demo is connected to the NAT because it's a private one, isn't it? Right? Now, the public one, right? The route table entry are connected to the internet gateway because it has to connect to internet. That That's, because that is how we are going to connect from outside, from our PC to resources, which is in VPC. So it is connected to internet gateway, this public one. And by default, we added a NAT gateway, so it is connected to NAT gateway. You can see these pictures, right? Now this is your VPC, right? So VPC, you have CIDRs. What the CIDR we selected, right? Associated. You can see, right? You have flow logs, right? We don't have currently. When we add more resources, the logs will come, flow logs, right? Tags, we gave the name demo VPC, that's fine. Integration, if you have integrated some other services with this VPC, for example, CloudWatch Internet Monitor, it gives you traffic, the uses of resources, how much it is used, and all those things we have not added. So for now, we'll leave it, right? This VPC has details, VPC ID. So this is the ID which the VPC, the Amazon has by default given us, although name is, excuse me, name is the tags. This is the name, right? But VPC, the ID they have assigned for us, right? State is available. Everything is properly configured, right? You have a network access table default. We didn't create it. While we're creating, it automatically create default, right? Default for ours, Amazon did for us. Main route table, right? This is also a default route table created for our VPC by AWS. Now, once we get experienced, a little bit more experience, we'll do all these things ourselves, right? It doesn't have any entry. We can add entry, right? To be this VPC, you don't only want, for example, HTTP access or an SSH access. So you can only give those accesses. Other accesses, we will block it, right? We have not gone, the slides still are there, right? Now, this is what we created, this VPC. Now, we can simply go to your VPC, right? This is the default one. We don't care about this now. We just created the demo VPC. So if you select this demo VPC, see, you can see the details which we were seeing, right? Resource map. You can see resource map. From resource map, what's happening here, all flow logs, all integration, right? Details. Now, see, while selecting this, if you click subnets, right? This VPC has what? Two subnets. This is a VPC ID. We can't select it. AWS gives us. You can see other options here available of, this is the CIDR block we used, right? IPv6, we have not given this. DSCP option set. Now, this rule is, again, a little bit advanced for us to know, but AWS has given us this main route table, which is empty for now. Main network ACL should be empty as well. Again, we have created tenancies default. Is it default VPC? No, it is created by us, so it will know. Who is owner of this VPC? Me, right? AWS Manish Singh. You see, this is my account ID. Even if you create an IAM user, that it will be associated with this account ID, right? That's good. Let's let's look at subnet. Now we can simply click this one, right, and see the details as well, isn't it? Or select this and below it comes all details you have to see. Now let's see subnets, right? Now these subnets you can see are already there. These for default VPC. The default VPC automatically came. So they have 3 subnets. We don't care about this. See, how do you know? This ID, VPC ID, VPC 06, blah, blah, blah. And at the end, 368, right? So you go, see, 368. So this is associated with this VPC we done. The subnets we created are this, and it has name as well. We can rename this service as, while creating, or simply here, right? Like this, private or public one, whatever, right? We'll just use the default name. Now, each of these subnet, when you select, you see, right? You would know, obviously, subnet name and subnet ID and which VPC it is associated with. We know this is our VPC, demo VPC, right? This is the VPC ID 85A. You can always go back to VPC and check if it is our VPC or not, right? And then see the IP address we gave, right? The CIDR we gave, I selected 2.0/24, 1.0/24 for both of the subnets, right? Now you have, you see, this is the private one, isn't it? Right? This is the private one, right? And this is the public one. Now, one question I would like to ask here is, and please answer quickly, or I'll quickly move on. I need more time, right? So you see, for this one, for this subnet, which is a private subnet, I have 251 available, and that is what? Because 5 IP, remember in the slide, 5 IP is reserved by AWS. So we can only have 251 different resources within free IPs, which you can use to put resources, right? But for public IP here, it's only 250. Why? Why not 251? So public IP is in public, subnet. For private subnet 251, for public subnet only 250. Why? Think about it. Okay. So let's just randomly select one of our subnet and see the details. This is subnet ID. You have the CIDR you have given, which availability it shows, it sits on, right? Available IP, right? This is ARN subnet, ARN, right? This is emerging specific naming convention. We'll see why we can use that for other things. For EC2, we'll see from outside as well, right? So these are zone ID, and you can see network product group or this VPC, right? The subnet is of this VPC, you can say, and owner ID, all those things. You have route table as well, right? You can click this and go, or you can see some full logs on from here. You can go, right? So you can see there are two route tables, two routes added in this table. What table? A route table, default table, which was created using subnet private, this private subnet while we are creating, right? This is the route table here, right? You can click that, go, or you simply see here. One is default 192.168.0.0/16, that's a VPC CIDR, and the target is local. Another one you see 00040 octet/0. So from anywhere to NAT. Now this is a private one. Remember, we added a NAT resource, a NAT gateway. So this one, right? This one, any traffic coming from anywhere should go to this NAT, and NAT will decide where to forward it. That's why, to make this private subnet accessible from outside, we added a NAT. So that's why there's two entry. You can add as many as you entry, right? Editing this route table. Similarly, for public subnet, you can see same details, right? Similar details. You have a route table here. The IPC IDR you are done. Network ACL could, network ACL I'll come back to, right? Route table first. Now route table again. This one, is default. So this is for local traffic. From anywhere, anywhere going inbound, outbound, you send to the internet gateway. IGW is what? Internet gateway, right? Which was again by default created when we were creating. All of these things are by default created because we use VPC and more, right? The other option, if you use only VPC, we have to create these things and add, and we'll do that as well to get more experience. That will check our understanding, isn't it? But now, for demo purpose, I did this, right? Now, remember, coming back to this question, I have a chat as well here. Okay, Jason says, when I ask this question, 251, why it is 250, right? Now, one of you suggested that it's internet gateway. You are almost close there. Remember when I said, when I was in theory, the slides, when I was talking about the slides, right? In the slides, basically, let's go to the VPC endpoint. No, VPC point, no. The same. Yeah. So internet gateway basically will get an automatic public IP. So we don't have to do that, right? Now, when I was talking about NAT gateway, remember, NAT gateway has to be inside the public subnet. although it is created for private subnet, we do not put NAT gateway into private subnet. So we have put, they created and they put directly into subnet, public subnet, which is, right? And then private subnet route table will be 0D000. That one goes to NAT. Any traffic goes to this one, right? So that is why the NAT gateway has taken one of the IP. NAT gateway is a resource, isn't it? That's why public IP has. So you are correct, and slightly, if you modify, then 100% correct in a way, right? The NAT gateway has taken this. Internet gateway doesn't take an IP unless we specify for other purpose, advanced purposes, which we are not dealing with now, 250 resources. So you can have 250 EC2, for example, 250 virtual machine here, 251 virtual machine there, or any other resources. This is taken by the NAT gateway, right? And route table is exactly as we were seeing in the slide, right? Route table, you can see. For private gateway, this NAT. You can click this NAT and look details of this NAT as well, right? So this is on VPC, details of this NAT, secondary IPv4 address. We have not assigned it, right? If we need, we can assign it. Monitoring, traffic, we can monitor many other things, tags. So these are kind of right from NAT gateway. From here, elastic IP have been created, and elastic IP one should have been created. See, that's a chargeable service. Now everything this we will do ourselves, so it will make more sense. Now for us, they have directly created and maybe attach it to allocation ID. This one attached to which one? This has a private IP, so it's sitting somewhere. Have they attached to resources? So this IP, you can see, this is the public elastic IP they have done. They have allocated to us and attached to this network interface ID. Now this network interface ID could be assigned to, we can check as well where it is assigned. Okay, it will take time, but you see, to this VPC, obviously, to this subnet ID, right? And to this NAT gateway, interface type is NAT gateway. You can assign it to VPC, internet gateway, or NAT gateway. In this case, we have assigned it to NAT gateway. The system has assigned it to us to NAT gateway. What is elastic IP? It's just a public IP, which we need to buy anyway if we need from outside. So in a way, we are buying with AWS here. It's a fixed IP, right? So this NAT gateway will always have this IP. If we use auto assign feature, which is not available for NAT gateway anyway, for other resources, auto assign public IP, as soon as it restarts, you will get another IP. So it's not fixed. But if you assign this network interface, that's elastic IP network interface, or this elastic IP to a resource, it's always fixed. Right. So let's go back to VPC. We looked at, right, VPC, what VPC is, subnet is, we created and everything. Now for now, I think this much demo is good. Later we can go many things, and the more we practice, these things will make more sense. Now, as I said, rule of thumb, this is what I have made. While learning, any resource you create, while leaving, just delete it. Now, if I delete this VPC, theoretically, right, everything should have been deleted, which it will give you an error message, saying that first, disassociate this elastic IP, delete this, delete this, and then come back to delete this, something like that message it will come, right? So we need to be careful what we have created and delete everything, right? So let's start from NAT gateways. The NAT gateway has been created for us. If it allows me to delete, it will, simply you have to confirm, right? This is to save our money, right? Obviously, in production environment, you will not delete, right? Now, because I will be able to delete this elastic IP. Anyways, don't worry. When you start deleting things, right, it will tell you what to delete first. So elastic IP I can delete because it was associated with NAT gateways, and I have deleted that. So it may allow me to delete elastic IP, right? Release first, delete as in release. Now it's released, cannot be released because it is associated with some other resources, right? Following because the associate remove the association using disassociate IP address or something like that. So it associate dissociate it has not given me. Let me go to, or maybe the NAT gateway was not deleted at that time. I'll simply delete this internet gateway, deattach from VPC, right? Deattached, right? Now, will it be allowing me to attach, delete internet gateway? So delete, right? Route tables. Now, these are two route tables. These are for the default ones, right? We don't want to delete that. Let's say delete, right? It doesn't let me delete because it is associated with, I know I'm doing this because you will also get it, right? But the point is, please remember to delete everything so that even, doesn't matter if it is paid or not, while you are not practicing, you can do that, right? So internet gateways, that's not for me, is it? VPC ID 36, that's for default. I will just leave it at default. That's not my ID. Let's do the subnet. And we delete the subnet. Let's try. Delete subnets. So delete. Yeah, subnet can be deleted. Now let's delete the VPC. The VPC we created. I use a few minutes to delete everything which I could have not done. I just simply said, just to enforce that, please delete, so that with $100 we can try so many things in AWS, right? So VPC is deleted. Now it's a default one. I don't have to delete it. Subnets are deleted. You can see route tables are not deleted. Let's see why it was not deleted. Let's delete now. One or more subnets or edge associations and cannot be deleted, right? VPC ID 885A. So what is 885A? No, that's okay. So I have already deleted. Maybe it will take some time to be able to delete other resources so that I can delete this as well, right? Because in background they are freeing up resources. This is IGW attached to 368. Is it our VPC? Let's go and see. 368, no, that's the default one, right? Default one. Yes, default VPC. You don't have to, or if you are, unsure, delete everything. We can always create default VPC as well. If there's no VPC option set, there's no elastic LP. Let's we have released this one. Now let's release this. So now it won't be charged, right? It will have only charged for a few seconds, which I have used. We have already deleted. So that's okay. Eventually they will, remove this. Or if you want to see, okay, it will take time to, but it's deleted, right? Now let's come back to route tables, and now it's deleted. Delete route table. See, now I can delete it. Now the following is associated with some. Yes, but we have deleted those resources, right? Why it is saying that? Sometimes it takes to stabilize, right? That's the only issue, I guess. Anyways, the point is you should delete, right? Now see, there's no subnets. These are other subnets, route tables. Now there's no route table. I have already deleted that, right? Internet gateways, default one. We just check if it is default or not. NAT gateways we have deleted. And elastic IP we have deleted. So now I'm safely, I can log out. No money will be charged. Yeah. Because I don't have $100, right? Like you guys, I have free tier account, I can use it, but these resources will be charged to my account, which is not a big deal. A few dollars, I can afford that. But I'm just showing you guys that this is the best practice to do. Right. There were a few messages. Okay, so let me check the time. Okay, let's go to main chat. Okay, don't forget your attendance. I'll have to stop, I guess. Hang on, I will